Hello everyone, I'm Sangbo, who designed and developed MACA Suite prototype. First of all, I would like to thank everyone who came here to watch this video. Today, I'm going to introduce this application and show you a real quick demo. For those of you who have used an interface engine before, who haven't used but interested in, this session will be very helpful, I believe. So let's get started. What is MACA? MACA is an interface engine suite written in C Sharp. It natively supports C Sharp, and it supports now .NET 9 Plus, and it composed of two main apps. The first one is Macadamia, stands for Development and Management Integrated Application, which is a front-end IDE built with .NET MAUI. And this designs and builds the Macaron services. The second one is Macaron, which stands for Run on .NET, is a backend server built with ASP.NET. And this loads and manages, deploys, and start-stop Macaron services. Then, what is Macaron service? This is a standalone background service. This executes predefined or user-defined codes on the Macaron server. It communicates with other Macaron services or external application. So, start install the Maca suite. As I mentioned, Macaron has Maca has two applications, which is Macadamia. So, in order to develop the services, you have to install Macadamia first. If you go to the MS Store, there's a Macadamia page, and you can click the download button, and it will download a small executable file here. Then it will redirect you to the other installation page. You can click install. Takes a little time, but it will be done in shortly. Once you install the Macadamia, you will see this first look of full instance page. This has three main sections. The first left is the Project Explorer or Model Explorer that I'll explain later. And in the middle is a model viewer. And on the right side, there's a templates area. And of course, you need a kind of tutorial to play with this application. So on the right top, there's a tutorial button. And if you click this one, it'll open up the tutorial, which is a part of the installation. If you go to the directory, there's a Maca folder that automatically created once you install the application. And there's a two folder, Damia and tutorial. If you look at the location, you will see that Maca Suite tutorial.pdf file is there. So it loads that file once you click the tutorial button. Today, we are not going to go over entire pages of this tutorial. We are going to go over shorter version of the tutorial. So we installed Macadamia. We are not going to install Macaron for now, but we will in shortly. First, what is the basic of the Maca development? So to explain that, there's a scenario that gives you more idea about the how Maca can be developed. So your client, WA Healthcare, Washington State Healthcare, has two locations, Seattle and Bellevue. And each location has a window PC that has Macaron server. and you are assigned to implement the Seattle location's requirement first. From this scenario, there are a couple of keywords that you are looking at: the client, location, PC, and requirement. The reason why I highlight this keyword is in order to develop the uh, application, you may focus on what are key concept of models. So throughout this tutorial, some models are expressly stated, such as the service, but in most cases, there are these key models will be displayed. The first one is the domain. As you see in this icon, which looks like the building, is stands for your client, such as company or even website. So this is highest level of the model. So you can put the what Washington Healthcare as a top level thing. And below it, there's an instance which stands for sometimes computer or sometimes mobile devices, whatever it could be. And this is part of the domains, and it belongs to the domain, as I just mentioned. The third one is the project you will mostly work with. It contains group and services. Of course, this is also belongs to the instance. It has a hierarchical structure. Then there's another model group, which is sometimes called service group, is a group of services. And lastly, we have the services, which is macaron service. This is standalone service belong to the project or group, as you see on the right side as hierarchical. It's pretty simple structure, like as you see in your Windows Explorer. So below it, there's a references table, and it has the domain, instance, project, and group. This will be covered later, but just briefly mention that each domain has a reference in it. So it can be added as a reference key, like domain, instance, project, and group. By using this keyword, you can access saved values like in sending facility, like this format. So just take a look at this model, which is very important while you implement the project. So let's move on. So how MACA works? As I mentioned, the top level, the client, for example, this client A, which is your customer, let's say, kick off project A. And you, a developer, or sometimes called interface engineer, analyze the requirements. Then you will use Macadamia as a main tool, IDE, to develop the project A. For example, create the services. And as we briefly went over, you mostly structure the project first and then start building the services like this way. So we have a client at top level, PC1, sometimes called the computer as PC1, but it is hypothetically assigned. You can set a different name that you can identify more clearly. And then there is a project A, and then it has a default folder testers. And of course, there is another service belong to the tester, which is the tester services. And there is another service, that's service one. Once you develop this project using Macadamia, you can load the project services to the actual client machine. For example, this is the Seattle location and name the PC1. And this is exactly the same structure of what you develop from your machine. Sometimes your client may provide the same machine when you are working in their location. So this will be exactly the same structure with the Seattle PC and what you developed. And they may have another project kick off, like project B, and then that might be related to the Bellevue location, which is Bellevue PC. And in the same vein, you can develop this structure and then load project A, oh, in this case, project B, to the Bellevue PC1. And these project will access to the web API in other applications such as EMR or interface engines such as Merge Connect and Info. So let's introduce some kind of good feature of the MACA suite. So this is demo. First, we have to analyze the requirement. For example, this is the hypothetical client, Washington Healthcare. And then there's a first location, Seattle, that we will focus on. And there's a one instance, which is PC. And the objective for this project is the first one is HL7 version 2 message handling. In our case, this will be ORM 001 message. And second one is web API consumption, which could be accessing the web API and do some image related activity. So this is real uh, short description, but this will give you more information when you look at the tutorial that contains most of the content in this. So let's implement this scenario. The first one is ORM message handling. As we saw before, the part on top of here that we have to interact with the application by sending the ORM. So the first thing we have to do is we have a DICOM file, and the DICOM file has internal values, and we have to parse that and then compose the ORM. And then after the composing, we have to send that ORM message to the target destination. In our case, same macaron service, which is ORM listener, but in the long run, it will be your actual client, such as EMR or interface engine like Merge Connect, as I mentioned before. So the key services in this first implementation is three services. The first one is DICOM reader, which is code repeater. The second one is ORM sender, which is HL7 client, which is dedicated to the external or internal services, which is HL7 listener. So we are going to implement three services to finish ORM message handling. In order to do that, there are a couple of prerequisites. The first one would be obtain sample DICOM files. I mentioned in these three sections, Lima site has the FTP server that has multiple DICOM files. For this tutorial, I'm going to use this CT image downloaded from this FTP server. I'm not going to dive into how to download, how to implement. You can check the tutorial for more information. But the short version is I use the FileZilla to access this FTP server and download and extract it. So the second thing after obtaining the DICOM files is to have a viewer. In my case, I downloaded the DICOM, micro DICOM from this website. This is free. And this will give you an idea about which tab in the DICOM file can be used. It would be really handy to show you the structure and the values in it. And the last thing, which is also an optional software, is the interface engine that can be replaced is ORM listener, which means directly targeting from ORM sender to this application, which could be Merge Connect. So you can download the latest free version of the Merge Connect from this link. And also you can visit this DICOM tag references to identify how the internal DL library can help your implementation. This site, which is the DICOM dictionary site, has lots of tag that you can refer. So please take note of this site. It will be very helpful while you are working with the DICOM file. So we define all three services. So let's build the service first. But the first thing we have to do is define the client. As I mentioned earlier, the domain is the top level. There's a no button to create the domain first, but I will show you a little later. So, but before that, there is a one top line of the buttons. This is for instance. So this is instance button, and below it, this is the project button. This is the second area. So there is a button top left, let's create instance, and you can open the instance in clone instance. And if you have previously worked instance, you can click this button to choose previously used one. And once you're done with your instance, you can close it. And then you can delete insert the case. So let's start with the domain first. As our client is Washington Healthcare, so we may define the name as Washington Healthcare. You can put any information in here, but for now, just put the name only. And the second thing is instance type. You can define whatever you prefer. For now, MACA Suite supports the PC. This means we are not supporting Android or other applications such as iOS. So only works on the Windows PC. So even if there's a bunch of options here, like TV watch, this only works with the Windows PC. And the location is Seattle, and this machine to be assigned as a PC1 or whatever the clients assigned, like IP address, whatever they prefer. But for now, I will set this as a Seattle PC1 to identify this PC belongs to this Seattle location. So click the create button, and you will see that two models are created on the model explorer. And as I mentioned, this is the second line, which is project uh, buttons are enabled now. So there's a one create project model button, and then import project model button, and clone, and recent project model, and save, and register model to template, which is related to this area. And lastly, the load model to server, which is the Macaron server. So once you create this domain in instance, you can click the instance or domain. You can see the belonging information here. We didn't have any information here yet because we didn't provide any description for domain and instance. We just keep it empty. So you create the project. For example, we are going to handle ORM message. So it's simply said that HL7 older project. So simply send the order message to the target destination. This is sending order message. So we call it as a order message. Usually ORM stands for the order message. So once you create the project, there is a default folder named tester. So we are going to use this one to create the related services. In this case, the icon reader, an ORM sender, and ORM listener. So click this one, already clicked. And then if you click here, now it will show the correct service. So as we mentioned above here, we can directly create the service here, like this. And if you look at the service type, there are two options like code and HL7. As we selected code first, there are two options, the code repeater, which repeats every time based on the time interval. And the second one is request listener, which executes the code based on the external request by the other services. The second one is HL7 service type, and it has also two services. One is HL7 listener, which listens the HL7 message, and HL7 client, which sends HL7 message to target application for HL7 listener. For now, we're not going to use this pop-up to create these three services. Instead, to expedite the implementation, we are going to use the import that imports the demo file. So first one, the diagram reader here. Oh, by the way, there's a RON as a extension, which is run on .NET. So this will run on .NET. Okay. You can import, and it shows that the which information you want to modify before you save. So just keep it as it is. So, and it shows that there is one service, which is diagram reader. So we are going to use import again to import another one, ORM sender. Same as, keep it as it is, and repeat ORM listener. So we have three services under the HS7 Order project. What we are going to do is we have to connect each services to communicate. The first one is connecting DICOM reader to RM sender. And HS7 client and HS7 listeners is a little different way to connect. So I will show you later, but let's focus on the DICOM reader first. Based on the implementation diagram, this service reads DICOM files and parse in order to compose HS7 message. So if you look at this edit, this selective picker, there are three options: detail, settings, execution. The detail is straightforward, so you can go to the settings. Settings has mostly three options like config, deploy, undeploy. We have one 5 lines of code for deploy and undeploy no code at all. So what this means is that deploy is code only runs when this service is deployed. So it's not repeating, only executes when this service is deployed. So what this is checking the DICOM directory, and if directory is not there, and it create. But for now, you're not going to do that one because you're going to use the DICOM file and put in here, DICOMs. This is the location where this service was set. So this is MACA in DICOM, like this. So for now, this is for the settings, which means mostly configure the service and define some kind of when deploy, do something like this. So let's move on to the third thing, the execution, which is core part of the each service. This is the code repeater. It usually don't have the filter stuff, so it is so almost empty. But the other service will have the filter thing in case the service is interacting with others. So the second thing is the steps, which is the main part of the services. This has a lot of code here, not a lot, but has some code in here. What this code is doing is read the location, and if there is a icon file, which is the ct0001.pcm, it reads the file. Oh, by the way, go back to the settings in config. It has the 10 minutes intervals. Sometimes you can change this one as a once a day, like specific time, or twice a day, and you have the certain option to run this service at a specified time not the interval. It's like 6 a.m. and 9:30 p.m. But in this case, in our case, we are going to use this first option, which is every 10 minutes. This is recursive. Sometimes we call it polling. Back to the execution. So this DICOM reader service has the internal code. What this code does is, as we saw earlier, reads DICOM and parse and compose HSL message. For now, we're not going to dive into one line by line. So but let's just take a quick note about how this service works. The first thing is that there is a verify service button on the top right side of the viewer, model viewer. What this button does is it checks the syntax of the C# code inside, or sometimes checks the configuration is correctly done. I will show what that means later. So for now, with using this predefined code, just click this button, and it will kind of complaining with the compilation error. In step one is the type of namespace name string builder not be found, which is pretty common under the system text namespace. And the second one is the name DICOM file does not exist in the current context. What the DICOM file means in this context is you're going to use the DICOM file, but with a general C# or a general embedded DLL, we cannot parse or read DICOM file. So we have to add external DLL to do that job. The first thing is if you look at that button, which is a library button, which is manage service libraries. If you click this button, it will show you a pop-up with the 4 tabs: usings, DLL, NuGet, and fallback. We're not going to cover the fallback for now. But for now, we're going to use using first. Back to the compilation error. We have a string builder issue, so we can use this one. Here, it just close and then repeat. And that string builder related compilation error gone. So we have only one exception, which is the icon file. So go to the NuGet tab. What this NuGet tab is, it allows you to search the NuGet website to search whatever you prefer to download. So for example, there is a icon related library named fo-icon. And if you look at the result after you click the magnify button, you will see the list of the type fo-icon related result. We're going to use the first one, which is the fo-icon, exactly the same as the fo-icon, and which is the 5.2.2, the latest version. And then if you look at the here, .NET Standard, and there's another community toolkit, the high performance. This is the required one in order to use the icon. For now, we're going to download this first. If you click the download button, it will show the download complete. And secondly, as I mentioned, we need this high performance library as well. Put it here. Search. Then you have 2 results out of the search. Then click the top one, which is 8.4.1 version, and then also you can download here. So the next thing is we just downloaded, and we didn't add any library to this project to be used, because unless we add this library to the project, it won't be referenced. So keep showing the error message that we showed before. So we can add those libraries and click hit add button. And if you go to the MACA, have the MACA folder, and there is a Damia button. folder, and there's a works folder, which is the main location where you store your project based on the client. So you're under the Washington healthcare client, and also you're the Seattle AC one. And if you look at the structure, there are extra folder named the DLL. Let's expand that one, and you will see the NuGet folder. There are two folders, one FO Dicom and the other one we just download high performance. So first, we can add the FO Dicom first. And under the library folder, there's a FO Dicom core.dll, and we will use this one for this project. And there is added one, and you still have one more. Good stuff, but keep going. There are a bunch of installation. We will use this .NET 8 first. Then we have two required DLL files in our project. So if we add those two one, let's see what will happen after we click this verify service. We still have not seen the DICOM file designs in the current context, because even though we use that one, you still use this DICOM file instance or class. So we have to use the namespace of the DICOM library, which we didn't add in the using tab. We can use that one right below the system text that we added before, and close and hit the verify button again. And you will see the code defining here are compiled well, so that there's no error. Good. So for now, what we did was just click the all the required namespace and the required DLL files. The next thing is, let's look at the what this code does. First, we have to parse the DICOM file. So for your implementation, if you look at the DICOM file, as I mentioned, I use the micro DICOM. This shows the text on the right side, and in the middle, the image that this DICOM file contains. So uh, in order to implement the code, I'm not going to go over what actual ORM 001 message contains. We are just doing a real quick demo, so you can check this tutorial that contains HS7 message related information here. Okay. So the first thing is read the DICOM file, especially the text that required to send an ORM. For now, we are going to read the patient information such as patient ID and name and birth date, which is required for the Seattle location. I will show later. But you don't know where the actual tag located if you haven't used the DICOM file or even this tool. So first thing is that we have to use this DICOM tag here enum in the patient ID, so you can find patient ID, and then you will see that there's a couple of lines, but at the top line there's a patient ID, which is group 0010, element 0020. So you can use that tag as a identifier in this DICOM view. For example, this is DICOM tag list. So we saw that 0010, 0020. So you can find that text using that identifier. So this is the patient ID tag, and the value will be 0001. And the second thing that we are going to extract is patient name right above the patient ID. So the same thing can be done with the patient name. if you look at that, and you can find the tag with a 0010, 0010. But this is for only the HS7 related library. If you are looking at the other library instead, you can refer that one. But in this case, we use this Apple DICOM, which is the fellow oak DICOM. So if you use the other library to parse the DICOM, follow that. But but in general, you can use this one as a tag verification one, even if you cannot use this one, but it will give you some idea about where that related information located by using this XML file. So we extracted patient ID, patient name, and we may use this birthday, patient birthday later, but for now, can just keep it as it is. So we use these two sections to define this one. So the next thing is send ORM to the ORM sender, which is just simply receive ORM message and send, or sometimes called it forward, to the destination application. So we define this one. By the way, you can use this HS7 encoding and the other message object and segment object as long as you are using this referent.hs7.v2, which is internally embedded with the MACA suite. MACA suite use this hs7v2 library as a base library. So you don't have to put this using statement in here. It's already be there. So if you are haven't used this hs7v2, I highly recommend to use this one to compose this hs7 message. So for your information, there's a way to take advantage of that one. And there's a button, add H7 generating code. And what this does is if you look at these uncommented lines, there's a message object and there's a messages object, and then it will hit the generate H7 message button. It will generate the corresponding H7 message based on this syntax. So you can use this to create in C or even save the generate HSM message to play with this HSM-v2 library. So the next thing that I was mentioning was ORM sender. So the ORM sender, which is HSM client, does not do any special thing for now. It may filter, as I mentioned, it's different from the code repeater, which doesn't have a filter. It has the filter because it receives a ORM message from the other services. And once the ORM message receives, this can check the message if the expected value is not a right or missing or a different format. It will complain it's not good and then return as a filtered or corresponding result message. So as I mentioned earlier, if you go to the settings, there is a H7 client setup section. What this does is it is destination information. As I mentioned earlier, if you look at this button, verify service, and if you do not define any of the value, not to mention the code incorrect or invalid syntax, if we make not correct the value or make it empty and hit the verify service button, it will complain that please type IP address in settings.config, which is exactly that I deleted. And then if I restore the value, it says that it is verified. So the thing about this HSM client and HSM listener is connecting the target and the client. In our case, client is ORM sender and the target is ORM listener. The same thing is happening here. If you do not provide the port, it also shows the similar exception message This port is not provided. So back to the ORM sender. If the ORM message is expected but not ORM message, it will complain like this one. So you can use this existing one to filter out, or ORM listener, which is the receiving end, can find whether this received message is not ORM message. For example, ADT A01. So we have another issue with the ORM listener. We didn't go over this one, but just look at this one. It complains that the culture info does not exist in the current context. This is also kind of using namespace issue because we use the datetime and parse exact, which is affected by system globalization. We can copy this one and then put in the using as we did before. Verify. So it's pretty similar, not exactly similar, with the general C# editor like Visual Studio. In order to use the certain libraries class, we have to add the namespace first, otherwise it will complain. So back to the ORM sender. We didn't have any kind of code here yet, but to make some kind of example to give you an idea about what HS7v2 can does can do here in the HS7 editor pane. This HS7 message generator pop-up can be a part of your playground to create or test HSM message. All the syntax written in here, you can refer to their website. But for now, we're not going to dive into that one. Just we're going to show some kind of information how you use the HSM message generator in order to implement your requirement. So we have four sections like ORM, ACK, which is acknowledgement, NAC or NACK, which is rejected, in the custom ACK using NACK. These all information are explained in here, so please refer to this document. And if you click this button as you did before, and you will see all the messages based on this code. So we have four sections here. So we have four sections here. So this is the regular ORM message. Just to say that again, ORM. Then the second one is the ACK message, like this. So by using this, you can play with this HSL message generator to see what will be the result or HSL message look like. And of course, you can save using this button. But for now, we're not going to any logic in here. Just receive the message and send to the ORM listener. And what ORM listener do is this. So this is what actually the Washington Healthcare already do. Consider this as your client's application that runs already. So they will check the HSL message, which is ORM message, and if MSH4 is one, which is the Seattle, in two, which is the Bellevue, either one or two, it will reject. So this MSH4 in the ORM message header tag, based on that value, it will process accordingly. So we are going to use the CL, so we have to send MSH4 as a 1. So go to the diameter, and if you look at the here, this is the sending facility area, which is usually MSH4. What interesting is that we use this inst and these values. It looks like the dictionary in the C#. So if you go back to the slide, I briefly mentioned that this model can be accessed using this keyword and the values defined inside this model. So we are working with the Seattle PC1. So if you go to here, we can look at this your key, which is the dictionary key, and then you can use this one as a sending facility as a key. And this is the Seattle PC instance. So this could be value one, and you can add, and it will be this value will be accessed with this key. So whatever the service is, as long as it belongs to this instance, it will automatically check this one and get this value. So don't forget to save this one and go to here. And then you can see that this one is checking the Seattle PC1's reference. So the reference is part of the uh, MACA suite. Every group model, which is the domain, see that, instance, project, in group has internal reference area. So as long as it has defined key and value, it can be referenced in the corresponding or containing services. So this one, you use this instance value, which is sending facility, and the all other values are here. So we compose this one, and we have to send this one to the ORM center. Now back to the first question: how can we associate or connect between DICOM reader and ORM sender? Because we have to send ORM message after we compose to the ORM sender message source. So if you look at here, I can put the cursor in the line 28. And if you look at this button, this is add service request codes or simply request button. If you click here, and you will see that there is a one service that can be callable or requestable. So which is ORM sender, exactly what we supposed to call. So once you click the add button, it will automatically insert the auto-generated code. So as I mentioned, ORM sender, which is HSM client, expects HSM message. So we compose HSM message above. So using HSM encoder, we created segment, and mainly we use the HSM message as a message. And what we need to do is send this message as a first parameter or argument of the request async. So you don't have to worry about this one. It's automatically capture that one, which is ORM sender is good. It will automatically capture. So it will handle as long as we associate this one. So we associate this one by using the request async. And then next thing is connecting client and server. So we briefly saw that the configuration of the ORM listener here, right here. So this is localhost because we are testing only locally. If you work with a real client, they may provide some other actual IP address instead of this localhost. And of course, this port. And we have the synchronized port and address for both ORM listener and ORM sender. So, and of course, if the ORM message is not received, it will complain. But for now, we are just expecting ORM. For simplicity, we're just looking at the happy path only. And the step, as I mentioned, this checks the MSH4. And if the location is the Seattle, it checks the date of birth, which is PID7. And I'm going to show you what this actually does with that one, along with this default ACK setup. So the ORM listener specifically checks the PID7 field, but in our case, we don't extract that value. So let's see what will happen without that value. So we provided all three required services And of course, we provide this icon file. And it, the icon reader file will get the icons folder. And then once it checks the file and compose the HTML message and send to the sender, and ORM sender will send the ORM message to the ORM listener, and then the ORM sender will send back the ACK message as an acknowledgement with AA accepted and with a simple receive the message. So let's start deploy this one because it looks like we finished all the uh, services. Let's check again, verify, verify, verify. So let's deploy this one to the Macaron server, which we haven't installed yet, but just in case. So once you hit that load button, it explains that macaron directory are found. Please make sure macaron is installed on your machine. So go to the link here. You can go to the installation location of the MS Store. And you can click the download button and you can click that one. It will do direct if you have a Microsoft Store app, and then you can click the install button. It takes a little time, but won't take that long. Now we have a backend server, which is Macaron. And this is an ASP.NET server. So it opens the port 7202 as a HTTPS port. So we can use that one as the main location to main destination to access from the macadamia. So again, we can try again with this service. And at this time, it's different a lot. Load the service group first. Okay, so tester, load project first. Okay, go over. Well, load instance first. Based on this experience, we noticed that the all these structure in hierarchically structured one needs to be uh, stored hierarchically as well. For example, if we go to the managed instance, which connects to the current server, you can log in here. Oh, by the way, there is a default user when you create or when you install the macaron server. The one is the admin, ADMIN, the same username and the password. And you can use that one to sign in without creating the user, like sign up below here. So you can use that one for your test purpose. And you can use that admin account, and you will see that there's an admin account is logged in, and you can use this pop-up to change or add more information. But for now, we are just using admin as is. So there are two tabs like the uh, development workstation. So there's a one source and instance. What these two tabs do is the source is as it states the source. Once you develop the sources, you you will have to upload these all entire models to the server hierarchically. So the thing is, we don't have any source in here, so we have to have the top level, which is the Washington Healthcare. So we have to upload that one. So just click the Washington Healthcare domain and then click again with this. And it shows that the process all containing service as well. If you click the no button here, only the Washington Healthcare domain will be uploaded. So if I click no button and Washington Healthcare loaded, and if you switch back to the management and source, and there's a refresh button, only this one will be loaded. So back to the development workstation and click is already clicked. So at this time, we can click the yes button to load entire models. So switch back to the management. As you see, we have all three services under the tester service. For now, we don't have any instance running on this macaron server. So same thing again. If you want to deploy and start the service, you have to hierarchically deploy the model first. In this case, the highest model, which is the Washington Healthcare domain. So if you hit the DICOM reader and then click this, there's a deploy button, and it will complain, please deploy service group first. If you click the higher, which is the tester button, you have the same error message again, like please deploy project. So again and again. So the first thing is that you have to deploy the top level one first. In this case, same thing. So in this case, we will deploy all containing models. And if you go to the instance, you'll see only the model deployed. The reason why the containing three services were not deployed is that this is the macaron server. If you stop the server and restart, or if you restart the machine, like Windows machine, it will automatically start. If the services is just for testing purpose, that is not supposed to do some kind of uh, important job. It's supposed not to be deployed and started. That's the what testers folder does. If the server restarts, the services under the testers won't be deployed and started. That's what it designed by design. So we have to deploy each service one by one. For now, the end point, which is ORM listener, is the first service to be deployed. So you can select the one and deploy. And this is deployed. Okay. And then it is ready to receive the order message. And the second thing is to load the client, which is order sender. Okay. And the last one is icon reader. If you the deploy or deploy and stop the service and then restart, it will automatically execute the containing code, no matter what the time reach it. For example, if you deploy this icon reader for now, it will automatically execute. And then after 10 minutes later, it will, or about the 10 minutes later, it will execute again. So deploy, and then there are three services running on the macaron server. So if you look at each services, it shows some kind of information in right side. And let's say that what will happen in the ORM sender. You can set it today, and it says this succeed. Okay, the message is received. The first one is what we sent, and the second one is the ACK message, what we received after sending the ORM message. For this message, even though we sent the entire ORM message, by design, MACA doesn't store any information other than MSH header. Because it is sensitive, it may be a violation if the information is stolen because macadamia in Maca run uses the embedded SQLite database. It can be viewable with other users. So it just saves the message header only. So look at the autumn listener, what was happening. And it said it was filtered. Let's see that. So it says object reference is not set an instance or object, blah, blah, blah. So even though it says the succeed and it returns as a filter, the reason why it shows the, by the way, I have to stop this one because it recurs in every 10 minutes. Just start for temporal. Even though there's a problem in the listener side, it always show the succeed because the ORM listener always sends the AA message, no matter what the received ORM is invalid or corrupted or not valid. It always sends the AA message. Sometimes the client maybe complained once they send the ORM message or other ADT or SIU message, they don't want to be bothered by the received ACK message like AR rejected or AE exception or error message. So to avoid that kind of situation, because the message can be sent sometimes 100 or 1,000 times in a minute. So if the error message due to some other an exceptional case, this without this sending AA message, whenever the error uh, comes up, the client will bombard with the error message. So sometimes the client don't want that. So in that case, the ORM listener can set that whether the message is the invalid or error or missing certain field or component, subcomponent. It will always send AA to prevent that kind of error prone situation. So, but in other case, like this one, do not send AA all the time, which means it will send whatever it was designed to. For example, if this parse exactly PID 7, in that case, it will catch in this HA7 exception case. So AE, and with the message, and it will be sent accordingly. Like if that is related to the HA7 exception, which is HA7v2 related error, it will send this, or if other exception, it will send this one. So let's see what will happen with this value. So verified, and at this time, you don't have to deploy entire thing, just one, because we already have the hierarchically all higher model. So just load ORM listener, load it back to the management workstation, source, refresh, and ORM listener, and deploy. And as I mentioned, if I restart, this will execute internal code. So before that, just check the what is the last one. So today we have only one. So if I start this one, okay, and then retrieve the ORM sender for today. Now it has the error message, unlike the previous attempt, because at this time it won't Let's see. So it won't send to the autumn listener because it has the filter, like MSH 9.1. So even though this is the one, you may not uh, pass the autumn message to the one. So in this case, we may just ignore that one. Just keep this one. This other thing, just thing one can just take message one uses finalizer that once the message was received from the autumn listener. So uh, you can just make sure that we have autumn listener, and then we just uh, deploy this one. But the still this autumn sender pointing at the previous session, so we can stop the one to make sure the refreshed autumn listener is correctly working with the autumn listener. So this again, and then we can restart instead of this stop and start. By the way, can retrieve. We have a two history, and then autumn listener, which is recently deployed, has no history because previous session was done. So we can restart. Oh, this is already started. There. Let this one deploy first. Let this one deploy. And just in case, we can freshly start over. Our listener, sender, then one succeeded one, and three still error. See the here, PID7, and there we go. So it complains that PID7 is not provided. So because it doesn't have any accessible value in PID7 location field, so complains that and returns as a filter. But at this time, autumn sender doesn't receive like succeeded before. See that? The ACK but at this time doesn't have the message, but in here it says this error message. So back to the development. Now it strictly check. No, we know that it strictly checks the PID7. We can add that value here. This is birth date. Then we can comply. Okay, and we have extra value, which is PID7. And then of course we can just upload this one back to the source tab, fresh. And at this time, we have a patient date of birth filled. And let's see what will happen if I deploy this one, which starts again the internal code of the diameter. So in ORM sender, we just received the message from diameter. At this time, it shows the succeed. Okay, we have a AA message in here, succeed, because the autumn listener checks the PID7, and it had at this time it had the PID7. So we stop this one. So we just implemented the first requirement, which is the ORM message handling with the three tachometer, ORM sender, and ORM listener. So let's move on to the next implementation, which is Web API handling. At this time, we reuse the DICOM reader, and with that, you can use the post image uploader service and get PDF downloader service. Two extra services to consume Web API to extract the DICOM image to upload to the Web API, and then Web API process that image in producing the zip file containing PDF file. So the first thing we have to do is we need some kind of extra environment, like Docker desktop. And along with that, we need some kind of other uh, tools like .NET Dev Search tool, because the web API is not running standalone in HTTPS mode. So we have to use these certificate tools. This is also in the scenario. You can use these tutorial to trust the self-signed certificate. There's a section that related to this stage. So we need Docker desktop to run the web API. But for now, let's see that we have two extra services that we have to implement. So as we did before, we can import the services instead of creating from the scratch. But at this time, we may take a little different approach. So you can click the Seattle PC one, because this is the web API. So we may use this one as a separate project. Let's say some other web API project. For now, MACA provide the web API for this file handling situation. So we are going to use this one as a main source to implement this requirement. So the first thing is that we can use this project as MACA web API. So if you are familiar with the web API, the address, the entire address, for example, this is the address, can be divided into two sections in most cases. First one is including the port as a base address. And then it will have the default testers. But in this case, we may have another group folder, which could be used as a root of the web API. So in this case, we can set the root as a files for simplicity, which is the API/maca/files is files root. So based on this structure, we can create these related HTTP method services like HTTP get, put, post, delete, something like that, like this one, post, get. So we start with that to make sure these services is handling web API. So we can do this again with the demo file that we already made, like get PDF download, image uploader. So before we use this MACA web API to handle this extract image and the download the zip, upload image and download the zip file, we can use this JSON placeholder website to play with little more before we use actual MACA Web API. I have some kind of tester here. Just leave it as a simple one as is. So what we can do is we can use these tester services to play with the sample web API, which is the JSON play server. So if you look at the steps or maybe filter, this is doesn't have filter because this is the code repeater. So go to the steps and you will see there is uh, add web API call code. Click this one and you will see that there's another pop-up that specify the base address, root, and get, post, put, and delete, and execute button to play with the web API client. This UI provides you a way to expedite code implementation. What the expedite means is it will generate auto-created code based on the configuration that you specified in here. For now, we are going to use this JSON placeholder, this code as a base address in to this as a root and just simply hit the just uh, set it get as is and then do nothing. Just click execute button. You will see the entire target address, which is the typecode.com.todos, and below that there are arrays of the to-do elements like this. So what this does is this web API client UI helps you to play with the target destination as long as the target destination is up and running. So you can play post, put, delete, of course, and get. For example, the get has the ID, get ID right here. So let's see ID. If the ID is 1, what will happen? Execute just ID. And it shows only one element related to the ID one. So alternatively, you can use query string like user ID 1 and then add query string here. So what this means is you will filter out the to-do list along with the user ID 1. So if you set the user ID 1 and execute, all the related results along with the user ID will be returned. And you can even filter out more, like completed as a false. If you look at the previous result, there are a couple of to-do item with a completed false and true. So we're not going to retrieve the true, only false. So add this as a query strings, and then you hit the asterisk button. And this time, there will be no completed true, only that. So the reason why I show you this UI is you can use this one as a baseline to implement web API consuming code. So once you have this one, like user ID completed, and then base address and root, or even you can choose the post, then you can click insert code and close. And if you look at this return code, those added auto-generated boilerplate is what you can modify to support what the requirement expects. Like the user ID is prefixed like 1, you can define this one as a variable like underscore ID or something else based on the past or environment. So using this web API client UI, you can play and add auto-generated code based on your configuration. So back to the MACA Web API. The first thing is get PDF downloader. There are already predefined code. But before we look at that, can check the MACA Web API. Same thing here. In the root, in this case, this one, and keep it as it is. Or we may look at the same thing that we did in here. Now we don't have any kind of uh, documentation of the web API. So for now, we can just use the get ID as a one, which is the Seattle location value, and then just click the execute to see what will happen with this. So it shows that no connection could be made because the server is not responding because we didn't start the server yet. So in order to do that, as I mentioned earlier, we have to have the Docker desktop. There's a currently Docker desktop is running, so it's okay. And the second thing is pull the image from the Docker. In there is a section about this Docker, how to create the certificate, self-signed certificate in trust, and how to pull the image and how to run the Docker image and run the container. So you can refer that all later. For now, we're not going to go over that. Just run what I already downloaded. Like, so we have the Docker image in my Docker storage, and then we have the certificate that have to use in here, copy in here. Then the next thing is cut in again and start the container. So we have running container. And the next thing is, oh, by the way, there is a section what each options means based on these highlighted value, which is pretty long. But you will notice that this won't be hard to follow, but you can use this one as a reference to install and run the application. So we have the running MACA Web API and go back to the web API client UI and do it again with this base address root and get ID, which is the uh, location ID. And before we do that, we can go to this page again and refresh it and see what will happen. At this time, we have a different result, which is the documentation. By the way, MACA Web API doesn't provide any kind of user testable UI such as Swagger something. We just use the plain open API documentation by design. So what we are going to do is call this API slash maca slash files and location ID. In this case, location ID is 1, which is Seattle. So we put the 1 in execute. At this time, this is a little different from before previous execution. And there's no value under the target destination because we don't have any data to download from the MACA Web API. So just close this one. And before we get download, all we have to do is upload images first. So if we go back to the spec, there is a posting API. Posting is uploading the JSON document, which is not clear, but it requires JSON document with three properties, which is the location ID, patient ID, and date taken, and of course the image. You're not going to test that post with the web client UI because the API, the post API returns the zip file, but there's no way to extract and download to the specific location using this UI. We just check whether the server is up and running. So that's all we can check with that, but we can check the other get something else if as long as the web API supports. So for this one, what we can see is the service type is request listener that we haven't used before. The request listener actually requires some certain kind of the argument. In this case, we need patient ID, date taken, and DICOM location to execute successfully define code in here. So the value when other service call and pass as an argument can be uh, accessible using underscore value, such as if we have a patient ID defining here, and we can use this patient ID by using underscore patient ID and underscore date taken, and lastly, but not least, underscore DICOM location. So we are ready to receive as long as they pass the argument, and the parameter can be used in here like this. So the JSON content that the web API expect with the location ID, patient ID, and date taken as a JSON content can be defined with passed value that are extracted from the DICOM file. Or sometimes you can use the location ID from this instance value as we did before. So in order to uh, compose that, we can take advantage of this one. But at this time, it is so annoying if we keep typing this address whenever we open this web API client UI. So to make it a little more easy implementation, we can use the references of your model, like sending facility in instance model. So if we look at the project level, you can use this description value that we added here, and then can use this key as base address. And then this value can be referenced as with a base address key and save. And of course, the file, same. You can use this root as a key and files as a value. And of course, save it. Now we can use these two reference in the web client UI. How? By checking this hierarchy, model hierarchy. If you click this MACA Web API project, you will see that the key value. So just click this value, and then if you see that, add selected reference key. Click. It doesn't show the actual value, but it will show what is referencing. It shows that this project level base address will be used. And same thing for files, which is group, and it has a root, and it is defined as API slash MACA slash files. Same thing. Okay, so as we did before, getter ID. Of course, we don't have any data yet. So we are seeing that this by using this one, we don't have to use any manually typing value insertion and then swiftly value or switching if you have a more keys here by specifying base address and root, which will be more helpful than just manually typing. So we have this one. So we just make sure that the cursor is here, and then we have the requirement of the post one is sending the JSON content with the three values. For now, we have only one JSON content. For the post method, we have four options, which is JSON content, and the second one is string content, so for the noise. And the third one is byte array content, and the last one is multi-part form data content. In usual case, you may use the JSON content, which is the in the JSON placeholder case, you may use this one as a typical post and put scenario. But in our case, the MACA Web API for the image uploader, it requires multi-part. See here, you see multi-part form data, and then a part of that, the first one is JSON content, and second one is the string content, which is iForm file. It can be a string or byte-array content. So we can choose this multi-part form data content as a main object to submit, and then specify which one we can submit. So the first thing is JSON content. As we see here, there's a JSON content, it's a simple a sample one, and then there's no mention about the name, but the MACA Web API requires the JSON content as a named agent, and then you can just keep it as it is. You can just location ID, location ID, and date taken like this for now, but it can be changed later. But let's put this one as a JSON, and you can see that JSON is added as a first uh, content, which is content type is JSON content. And the second thing is the image file, which could be either stream or byte array. Let's say we have a stream content. So in our case, this is JPEG image, and you can choose the actual file location, and you can choose one of them if you have. This is for testing purpose. And the name of the JSON stream content is image by design of the MACA Web API post. And you can use the plus button to add the stream content. So we can execute this one to post this image, but for now we're not using that one just in case. And then we can just use this one as a uh, testing purpose. And you can just click the insert code and choose close. And if you see, there are a bunch of code which is auto-generated code, like JSON payload to the JSON content and string content for the image. We're not going to use the hard-coded one, of course, and we have to modify the code based on the what DICOM reader sent to this service, like this one. So they will send, the service will send those required value to this service, and then this service will parse that value and assign, just modifying field of the few property of JSON content, and of course this images as well. So DICOM image, which is the uh, JPEG, and then have to use these internal extra libraries. And then we are ready to submit this image to the MACA Web API. So we can just remove this for the time being, and then see that uh, we have these two, but we don't have any related image related library for this service. So with this predefined code, let's check this, verify that we have a similar issue with the namespace and the some kind of DLL, missing DLL to process the image object. So same thing as before. We can use this one. I'm not going to dive into deeper for this namespace. But you can use this one to add inside this using tab. And if you look at the next thing is you still have some other uh, error related to 6 labels in the RGB A32, which looks like related to the DLL, third-party DLL. So we already have some kind of FL DICOM DLL, but at this time we use the image, which is a little bit different from the previous code. So we have to have the extra DLL, which is DICOM file image sharp. So search that and then choose the first one, which is 5.2.2, and then download. And the next one is 6 label that process the image from the uh, DICOM image. Then search and select the top one from the result in download list. And as we did before, we have to add those two downloaded DLL in order to make this service runnable. Go to the same location. So there are 2 more library that we just downloaded. First one is images sharp, created. The next one is 6 label library. So we have 2 extra libraries to handle images from the DICOM file. So let's see what will happen once we add them and hit the great. So we have verified all the code defined in here using those third-party libraries. And of course, using the namespace that you just added. And this will upload the JPEG image out of the DICOM file based on the past DICOM location, because the past DICOM location is used to locate the DICOM image. So again, you're not going to dive into each code line by line. You just simply look at the code, like this service checks the DICOM image out of the DICOM file and extract using the memory stream and the other RGB A32 object, and also use the stream content to upload as a part of the multi-part form data content and post it. So and get the result, and then show the result in the result section in the retrieval result of the management workstation. So we have this post image uploader service And the next step is what we did before, like associate the DICOM reader to the ORM sender. Same thing. We have to associate DICOM reader to the post image uploader by sending the request that contains all the required arguments. So how can you do that? We can go back to the DICOM reader. Same thing as we did before. The first one we did was using this add service request to code button. Same thing. And now we have an extra service that we can call or request. The first one was the ORM sender, which is the HS1 client. But at this time, we have to request to the request listener, which requires the arguments. So we can select the post image uploader and click add button. And it will show this few more extra code because we defined in the post image uploader that this service requires three arguments from patient ID to DICOM location. So once you click this one, which is the request listener, it will automatically insert what the service requires. For example, patient ID, date taken, and DICOM location with the data type that the service requires. So the first thing is patient ID. As we did before, the patient ID is this one. So we can just simply copy and paste it. And the date taken is a little different. And then we can just copy what just used before as a combination of the two tags, which is study date and study time. And it will get this date time by using two tags for the date taken. And the last is DICOM location. In the for loop, there's a get files method from the directory class, which is returning the file location, including the extension. So you can use this one to specify the third property of the required args. That's it. So we will automatically send these defined value once we associate required value from the contact and see that. So left-hand side, there might be a syntax error. See, we have file in the taken. Let's see which one is. Okay, let's see. We're ready to deploy this one. So the first thing is we associated the DICOM reader to post image uploader. The second thing is once we upload the DICOM uh, file that was uploaded was the used for the upload, auto upload, of course. And the second thing will be getting the PDF image from the web API server. So the internally web API generate the PDF file after a certain amount of time, like 2 minutes. It will be better to submit first before we deploy the get PDF download. So let's start with the get post image upload first. And if you switch back to the management, as you see, there's no project for web API, MACA web API. So you have to click this one. But at this time, all the files will be uploaded, not the post image upload that I mentioned. Anyway, you can just put all the files to the server as is, because we can place later. So refresh it. We have two added one, which is not ready yet for this one, but it is ready. But the one thing that we have to make sure is that we have the DICOM reader that just updated, but not updated on the server. So you can check it again and download this one. And of course, you can just check this one first. So we uploaded this one just in case I'm back to the workstation, refresh. So in the server instance, we still have two running ORM listener and ORM sender. Just let it keep running. And then the next thing is we can just deploy the related models. But at this time, you're not going to deploy all the services because this service is not ready yet. So just you can take the one by one approach, which is the deploy all containing models in Node. And then this will deploy only the MACA. And then it has a base address, this one here. And then in the same way, the files. Nope. And it will shows this root in here as well. And then finally, post image uploader deploy. Yes. And now we are ready to deploy this service, but still not ready yet because the instance still has the old logic here. So we have to replace this one with a new updated logic that calls this post image upload. So deploy as we refresh and deploy this one. And once we deploy this one, it will submit the HS7 message to the ORM listener and then submit the JSON uh, and image to the MACA Web API. But before we deploy that one, just check whether the server is up and running. Yes, we are ready to go. And deployed. Deploy model finished. And if you look at the listener, we have succeed. Of course, we just sending the message, nothing special, ORM sender. We have just uh, sent data. And lastly, we have post image uploader. Let's succeed. Great. And we have three values that passed and no exception. And if we go back to the here, there's a save the one entities to in-memory store because MACA Web API use in-memory database to store the image data and also store the JPEG, the PDF file to be returned when the get PDF downloader request. So for now, we don't have any special thing here, but we can see that there are two more some kind of library validation. So same thing, tedious job, the system dot text, and also for the zip file compression. And those two namespace are required. And okay, so what this service does is the same as before, like getting the PDF zip file using the get async with the HTTP client. And then if there is no file to download in case of a 204, if you look at the spec and if you look at the get file, this is the get. And there is a section that no content, which is 204. And it captures that and save this kind of info to the result message. And if that is not good, like other than 200, and it will capture that as an error and shows the error message. And the rest are using the stream to download the zip file and extract to a specific location, which is the MACA temp result, our main location here. And there's no result folder yet, but it will, temp, MACA temp result. It will create these two folders, subfolder, and then saves the extracted PDF file into this location. So we are ready to deploy, and we already have the previous uh, one, but we can load this one. Then back to the management workstation, then refresh it. Then we already uploaded DICOM, latest DICOM reader. And then the next thing is get PDF downloader to see if what will happen. As I mentioned, once we deploy that one, it will automatically execute the code. So it will download PDF file, actually zip file, and extract the PDF file. Well, it's finished. So it shows that extracted to this location with this name. And if you look at the temp results in PDF file with this uh, small amount of information that that the MACA web API is supposed to do for the get result based on this CT.icon sample file. It will not capture, actually image was uploaded, and using this image, the MACA web API create this PDF file with the headers and the small amount of patient information. That's it. For now, we're not diving into more detail about the how to redo or how to test or even debug or something. But for now, this will give you a bunch of idea about how to you can use this MACA suite to implement the requirements. For example, the healthcare digital message or DICOM file or handling web API consumption, or even you can use more productive one by using this NuGet uh, search API, such as there are a bunch of things like OpenAI, ChatGPT. You can take advantage of already uploaded to the NuGet store, and then you can take some of them and import in your application. So we just implemented all the requirement that I specified earlier, which is simple, but the core part of this demo. And if you have any questions or feedback, I'd love to hear. So you can directly send the request or email to the Maka at bakeyourself.com or directly to the Sambo at bakeyourself.com. So thank you for your time. It's pretty long session than I expected, but I hope you enjoyed this session, and I expect you to play with more with this prototype version, still prototype, and have fun. Thank you. Bye bye.